Okay, so what did you notice about the area as the number of sides got bigger? What is the area approach? Oh, what's pi? Okay, so you guys know a couple of them, a couple of digits? Okay. What happened to the perimeter as the number of sides got bigger?
It got 6.28.
It got closer to 6.28. What is that? Double pi, right? Okay. So as the number of sides gets bigger, what does our polygon get closer to resembling?
A circle.
A circle. Okay, so what would the radius of that circle be for all of those shapes that we did? The radius was what number?
1.
1. All right. So when our radius was 1, our area got closer to pi and our perimeter got closer to 2 pi. Here's a question for you. Is the circle a polygon?
No.
No. Do you guys know what the actual definition of a circle is? Caleb, what do you think?
It's a shape with points that are all equal distance from the center.
Yes, that's exactly right. So a circle is actually a set of points. And it's every single point that's that same distance from the center. And that distance is the radius. All right, so in this case, your radius was 1. Okay, so what I want you guys to do, I'm going to give you like 20 seconds by yourselves. I want you to predict what the area would be for a regular polygon with infinitely many sides and a radius of 1, and what the perimeter would be for a regular polygon with infinitely many sides and a radius of 1. Right now, no talking. Think and write down what you think the area and the perimeter would be for this polygon. All right, who wants to tell me what the area would be? Pi. And what's the perimeter?
2 pi.
2 pi. Okay. So here we go. We've got a circle with a radius of 1, and we see that the area is pi units squared, and that the circumference, or what we call the perimeter of a circle, is 2 times pi. Okay. Let's think back. Are all of these circles, or are all circles in general, are they similar?
Yes.
All right, so if this circle is similar to this circle, what is my zoom factor?
2.
My zoom factor would be 2. And what would the zoom factor be from this one to that one? 3. So last block, we talked about how the perimeters of similar shapes were affected by the zoom factor, and how the areas of similar shapes were affected by the zoom factor. Okay, so let's start with areas. If I want to find the area of this shape we saw it would just be pi, right?
4 pi.
Okay, so if I want to find the area of this shape, my zoom factor is 2. So what do I do to my zoom factor when I'm looking at areas of similar shapes? I square it, because remember, a zoom factor, it affects the length, but an area is 2 dimensions, length and width. So I'm multiplying by the zoom factor once for the length and a second time for the width. So if I do that, I would get 2 squared, which is 4 times pi, because pi is the original area. What about for this triangle here? My zoom factor was 3. What would the area for that one be?
9 pi.
3 squared, which is 9, times the original area, which is pi. Okay, my circumference, which is what we call the perimeter of a circle. My circumference for this was 2 pi. All right, my zoom factor is 2. A circumference is another measurement just of length. Same with perimeter, it's just a length. So I would take my circumference and I would multiply it by just the zoom factor by itself. So if my original circumference was 2 pi and my zoom factor is 2, what is the circumference of this going to be? 4 pi. Okay, what about the circumference for this one?
6 pi.
6 pi, because I would do 3 times 2 pi, and I would get 6 pi. Okay, So that's going to let us kind of generalize what's going on with circles. The radius, if you notice, the radius is identical to the zoom factor if we're basing it off a circle that has a radius of 1. So if my circle had a radius of 4, what would the area be?
8.
What's 4 squared?
16 pi.
16, and then times pi. And what would the circumference be if the
8.
radius was 4? 8 times pi. So we can generalize this for all circles. If r is my radius, the area of my circle is going to be r squared times pi, units squared. And the circumference of my circle is going to be 2 times r times pi. So probably when you guys were learning this, I would imagine you learned this somewhere back in middle school sometime, and they always say it's pi r squared. But really, you want to think of it as r squared times pi. For some reason, they always say it with the pi first, but when we write it times pi, pi last. And we kind of treat pi like it's a variable, just like we do with our radicals, our square roots. So if you know your radius, you can square it and then put pi at the end, and that would be your area. Or you can multiply it by 2 and put pi at the end, and that would be your circumference. And when we're doing these, for instance, if I had 16 pi units squared, you can leave it just like that, and that is what we call exact form. Or you could use your calculator and use the pi button on your calculator and multiply it out. And you would get a decimal that would be 50.27, I'm rounding it. And then as soon as I start rounding stuff, it's no longer exact, it would be approximate. I personally prefer exact form, leaving it with pi there because it just saves you a step. So you can leave it with pi. All right, does this make sense? Okay.